Hello, my name is Santiago Martinez, and we're going to be doing a problem from problem 6 from exam 3. And let's write this out together. So we're going to write a function for CSC of tangent inverse of 1 over x over 2. We're going to write a function as an algebraic expression and we're going to and we don't want to involve any trigonomic functions. So the way that we're going to do this, right, is we just have to know our basic principles. So right off the bat, I see this information and we want to figure out what it equals, right? So right off the bat, I'm going to be drawing a triangle. Triangle right there. And then let's analyze this first part, right? So we have tangent, inverse tangent of x over 2. We can simply write that as tangent of what angle gives us x over 2. Well, this is where a term that you should know called SOHCAHTOA. So SOHCAHTOA. Excuse me for that thunder there. It is raining outside. Sorry, that thunder really threw me off. My apologies. TOA must be getting ready to rain really bad. Sorry, I'm gonna go close the blinds real quick to make sure that you guys cannot hear as much as the rain. But yes, this is SOHCAHTOA, and we should know this. So this is sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So we should know that by heart, and we should be able to use this information, right? And how we're going to use this information specifically is we're going to use it to calculate our sides of the angle. So immediately we know that we have tangent. So tangent is equal to opposite over adjacent. So we can rewrite this as x is equal to opposite, and 2 is equal to adjacent. And with this, now we can fill in our information, right? So our angle we could put right here. This is theta. And we know that x is opposite, so this is going to be opposite. And then this is going to be 2 because it's adjacent. And you should leave this side, the longest side, for your hypotenuse. But we're trying to figure this out, is our h value, right? This is going to help figure out our overall goal, which I didn't mention before. But our overall goal is to find CSC, right, of this angle. So CSC, I'll write it up here, that way it's not in the way of things. CSC is equal to 1 over sine. So we need to figure out sine, and in order to figure out sine, we need that h value, which we can figure out, right? So our next step after doing all of this is to then rewrite this. We know that we can use the Pythagorean theorem, which I'll write it right here. I like to put it as P theorem. Is going to be equal to x squared plus y squared is equal to r squared. Another way of writing this as well is we can do simple terms of where our things are, right? So this in theory would be x if it was talking about a regular graph, and x ironically would be y. So we can also do it as adjacent squared plus opposite squared equals hypotenuse squared. Or another great way of writing it is however you need. There is also a Pythagorean theorem of the actual functions, which we'll use later on through the next couple of videos. But for the time being, let's just focus on this right now. So let's fill in our numbers, right? So we're going to fill in our numbers over here. So we should have x squared plus 2 squared equals r squared. Remember, this is a value that we already given that we think that we know, so we are going to be solving for r squared, right? So this is pretty simple. We should have x squared plus 4 equals r squared. What do we do in this situation? Well, we're going to take the root of both sides. So we have x squared plus 4 equals absolute value of r, right? But we'll make a little note here that we only want positive because we're dealing with triangles. So you can get rid of the absolute value there. And after that, that is going to be our hypotenuse value. So it's going to be x squared plus 4 is equal to r. So we can come up here and we can fill that in. H is equal to x squared plus 4 is equal to r. Pretty nice stuff there. And then in order to figure out the rest of our function is we're going to put, we need to figure out SOHCAHTOA, right? Or sine so far. So we know that sine is equal to opposite over hypotenuse, right? So we should have x over root x plus 4. Root, let's make sure we carry our root sign all the way over, right? So this is what sine is equal to. And if this was just sine, we would have to rationalize it. But since we're looking for CSC is equal to 1 over sine, we can simply rewrite it as CSC is equal to 1 over x over root of x plus 4. And then we can write that as copy dot flip 1 over 1 times x plus 4 over x. And that was going to give us root x plus 4 over x is equal to our function. So we would write it as CSC is equal to, CSC, make sure you write the entire thing out. Is equal to root x plus 4 over x, carry out your sign all the way, and that is our answer. So a quick rundown of the problem, just to make sure that we all know, is we given information, we use SOHCAHTOA to analyze that information. We rewrite our inverse function as what angle gives us this, or what tangent of what angle gives us this value, and then we plug that value into our triangle, making sure that we respect our rules, hypotenuse being the longest side, and then we use the P theorem to get our H value, or any value that could be interchangeable if we're looking for A or O, and then we solve for that. That equals R. We plug R back in for H, and then we use that information to figure out whatever's being asked next. So that's how you figure out one of these problems. Thank you so much for your time, and hope you have a great rest of your day.